do a short introduction and then.
Okay. Hallo, einen schönen guten Morgen. Herzlich willkommen zum Automatica-Forum hier auf der Messe Automatica. Ja, schön, dass Sie alle schon so zahlreich da sind, am frühen Morgen quasi. Wir beschäftigen uns hier die ganze Woche über mit den Themen, die die Automatisierung oder die Robotik vorantreiben. Das sind Themen wie künstliche Intelligenz, Digitalisierung, MRK, also Mensch-Roboter-Kollaboration oder Nachhaltigkeit. Und heute am Vormittag stehen die Cobots, steht die Mensch-Roboter-Kollaboration im Mittelpunkt der Keynotes. Wir haben dazu dann auch nochmal eine Podiumsdiskussion, die sich mit der Demokratisierung der Robotik, so wird das ja oft genannt, beschäftigt. Und wir starten heute gleich mit einem sehr spannenden Vortrag. Ich freue mich, dass wir Esben Østergaard gewinnen konnten hier für das Forum. Er ist CEO und Co-Founder of Reinvest Robotics. Und er wird uns, wie es hier auch schon steht, ein bisschen was über die Zukunft der Robotik erzählen. Und ich bin sehr gespannt. Mr. Østergaard, the stage is yours.
Thank you so much. Is my sound on? Yes, it is. And okay, you can hear me. Is the sound okay? Good, thank you so much. So yes, I'm the founder of Reinvest Robotics. I have the Engelberger Award, and I think I'm more famous for being the founder of Universal Robots. So that's also what I'm going to talk a little bit about today. So the agenda today is I'm going to go through Universal Robots because it was such a big part of what I've done in robotics. How that created the new category called the cobot. I'll go into history of robotics and history of work because I think it explains why this category has so much potential and is growing so much. And I'll talk briefly about this concept called Industry 5.0, which I think is the natural next step by 4.0, and I'll of course elaborate on what that is. And then I'll briefly go through what we're doing today, Reinvest Robotics, what we're working on, and also how I see the future of robotics. So I hope to get through all this in the next half hour. So many of you might know that the Universal Robots, so it actually started with a completely different project. So we made these super nerdy transformer modules in my PhD, which look like this. It's like self-assembling Lego. You can pour them out on the floor. They find each other. They start connecting structures. And that's what I did in my PhD work. So it was very useless, but a lot of fun. And you might notice the color of these shells is actually the one that later became the color of Universal Robots. We also did kids that had to learn how to program robots for Lego robot football. And to realize this, we had to make programming very easy and accessible. Otherwise, the kids wouldn't have, the attention to get into programming these robot football players. So we learned something about easy programming to do that. And we also had a project going on how could we make existing robots more flexible and meet the needs for, in this case, it's a Danish small food company that makes pizzas, and they need to make different kinds of pizzas throughout the year. And we tried with this ABB robot to give it the flexibility these guys needed to move it around and reprogram it. And as you can see on this picture, it's not a very easy task to take a huge classic industrial robot and give it the flexibility that these companies needed. So we had the technical insight, the easy programming insight and the user insight, and then also the insight of the lacks of the existing technology on what was needed in the market. And that is what made us create Universal Robots, where we started in, garage style. Here it's Christian Casso, the other founder of Universal Robots. And we were spending a lot of time coding with oil up to both elbows and trying to build this robot. And in the end, we managed to have a robot that actually worked. And in 2007, we had the first working prototype. And I think you have all seen them everywhere around here now. They're not so unknown anymore. They became quite famous. So actually in 2010 was the first time we brought this robot outside of Denmark here at Automatica. And on day one at the fair, we had no visitors in our booth. Nobody knew anything about us. But as you might see in the bottom right side there, we actually had the front page of the Messezeitung that day. So the second day we were kind of famous and everybody came to our booth and we started selling a lot of robots. And in those years we really had an explosive growth. As you can see in the number of employees, which is the rightmost side, we had a super steep growth curve. We more or less doubled the staff every year for 7-8 years in a row, and that was, of course, quite dramatic to be part of. And I myself also have gotten a lot of awards with princes, and here's Margrethe Vestager learning how to program a robot. And we were also the first non-human to ever ring the Nasdaq bell. And that I thought was very funny, because it's the honor of pressing a button, and it's probably the last thing you would want to automate. But sure enough, our robot was the first time a non-human did this task, which was fun. And I had a meeting with Al Gore and a lot of others. So it became a big thing when we sold the company in 2015, because at that year it was one of the largest technology exits in Europe. And it was, of course, a big deal. We sold it to Teradyne for $350 million. I stayed working there for 4 more years, but it was not my company anymore. So 2 things we did well besides creating the cobot. We also created an academy, which was about, you can say, lifting people up to understand the technology. So the main problem we are addressing is that there are not enough system integrators in the world that can actually do automation. So if we make the robot easy to use, and we train people to become better at programming robots, and we create this ecosystem around the robot that packages technology up in you can say, more digestible bundles, we have a winning recipe, I would say. So we make technology bundled and packaged easier to use for users. We lift the users up to become more tech savvy, and we make a robot that is as easy to use as possible. And that's kind of what was the recipe for Universal Robots. And today there are a lot of different companies doing the same thing. So 194 cobot models last time I checked. There's a website only tracking how many cobot models are out there. So it has really created a lot of attention, you can say, this idea behind the cobot. And it's also predicted to be a steeply growing market. So the estimate was $1 billion market size in 2020. That includes the integrators and the producers of accessories to the robots. And estimated $8 billion market size in 2026. So it's a steeply growing market. And the applications for the robot were also so many new things we had never imagined. So the Olympics in Rio had these robots filming both the swimming stadium and the track and field stadium, sitting like this in the ceiling over the commentators. We had this company doing TV studio robots. We have construction sites where these robots are coming in. And also landing an aircraft. This is probably the most crazy application I've seen. They use the robot as a co-pilot to land aircraft, and the rationale is that it's so difficult to go in and certify these old flight systems that it's better to put a robot on the outside that actually pulls the levers. So it's I don't know if I feel safe about this. It's only for cargo planes, but it's an interesting application for sure. And recently we were in Paris, and we saw also our robots producing pizzas near the Centre Pompidou in the center of Paris here, where a company has made an application where the robots are serving pizzas. And the point is that once you make robots more accessible, there's so many new applications that you open up, and that has been very exciting to see how many new applications the robots have been used for. Here it's used for interrogating an alien in the movie Valorant, where you can see the robot is here evil and interrogating a good alien that actually explodes a few moments later. And here's another movie where the robots pop up. So I'm very happy when I go to the movies and I see our robots used in the movies. It's always a surprise, but fun. And I also like that they never redesign the robot. They think it looks futuristic enough to belong in the future. So that's also something I'm very happy about. They don't need to redecorate the robot to make it look like it's something from a sci-fi movie. So I'm happy about that. But that was Universal Robots. So where did robotics come from? So the idea with Universal Robots is to make this robot into a tool. And that's actually a very old history we have since, I couldn't find a picture of a Stone Age man, but human evolution has been an evolution with ourselves as a species and the tools we use. And the reason our lives today are vastly different from our lives a few hundred years ago is not that our biology has changed, it is because our technology has changed. It's the way we used tools. So our evolution is no longer an evolution in biology. I think it stopped maybe on picture number 4 or 5. Now it's an evolution of technology. And yes, there are drawbacks of technology, but our lives are also better than ever before. We have higher life expectancy, less infant mortality rates, and in general, we have better lives than ever before in the world. So technology is generally doing good for humankind. So that's how we evolve today. It's an evolution through our tools. At the same time, we have this arts thing going on. We use technology to understand ourselves through technology also. And robotics also has some part of that background. So if you look back in all the movies and how the idea of a robot has been evolving through the various movies, they are often very scary robots, as you can see, but they're also very interesting. And that's why Hollywood and other big movie makers, they use robots, because they have this fear and fascination concept to robots, which is, I think, also why robots are cool, because they have this duality in them. Until the 1960s, robotics was in the arts world. It was in fiction. It was these movies that I just showed. But in the 1960s, the first industrial robots became useful enough to be used in automotive factories. And that's where we had the industrial robot arm revolution starting in the 80s and going on. And the journey robotics is on is from this kind of robots we know from automotive factories doing the same thing all over and over again all the time, and then to the future where robots are interacting with people and doing new things every time. And that's the journey robotics is on. And you can say the cobot is kind of a natural step on that journey, because it's less rigid than the old traditional robots, but it's not as flexible and safe as the future of robots will be. So we are still on this journey with robotics. Similar way, we have also used technology to create value in different ways. And the dominating technology at each era in our history has also defined how we create value with our industry. And these are the so-called industrial revolutions, where we had mechanization of agriculture, electrification and steam power in the second industrial revolution, computer-controlled machines in the third industrial revolution, and now Internet of Things and cloud and services as this fourth industrial revolution. So that's different technologies that have revolutionized how we produce goods. And then here's my big claim that we have lost something in that process. So if you look at the left side here, we have a fully automated factory producing cars, exactly the same product every time over and over again. And on the right side, you have endless lines of, in this case, women doing the same thing over and over again. And if you do a lean analysis on the picture on the right side there, you'll actually find there is some very important aspect missing, which is that human touch. And it turns out that human touch is something that is very valued by the consumers. They actually want unique products, well-defined products, and so on. So we're actually wasting something super valuable when we use humans like robots. And but that was how it was. So it came from a history of factory work being like this. All these people have work instructions. They are told exactly what to do at every minute, and they have to, keep the pace. And they are not allowed to think for themselves. And here's a small kick to the school system. That's actually also how we defined our own school system. We are actually training a lot of students to become factory workers, and that's actually not what we should be doing. But that's you can say that's another story. But even factory work is not always like working like machines. In the 60s, we had these typing pools of women who was just copying, hand notes from some boss or some letter that has to be sent out to 1,000 customers. And this was also revolutionized by automation. So when Bill Gates invented the word processor, he made it possible for the CEO himself to type his letter and send it out to all 1,000 or 10,000 customers. And we didn't need these endless pools of women in that picture to do that work. But it did, you would think that would change office work. There would be no more office work, but it didn't happen. More people today work in offices than ever before, but they're not just typing, the same letter, all of them. They're doing new things all the time. So the disruption the technology brings does not necessarily kill that category of job, but it just changes the content of these jobs. And that's the point here. So if you look across different job categories, you'll see that there's no job that's 100% automatable, and there's no job that's 0% automatable. So all jobs have some level of automation potential, and there are some of the tasks in each job that can be automated. And nobody's going to go untouched, but everybody is going to, I would say, benefit from it. And so that's the point. There's no single job that's going to be completely replaced by automation. And that's an important point. And then what is driving all this? What is driving the change? Why are we all not unemployed many, many years ago, since we got the steel mills and the harvesting machines and all that? It's because we all are unique. We want to do something unique with our lives, and we don't want to have the same product, the same doormat, the same whatever as the neighbors. So there's this concept of Industry 5.0, which is what can we do in factories to produce this human value, this thing that everybody seems to long for. And that is, I think, also a little bit what cobots did. It made it more easy for factory workers to become experts in their own processes and their own applications. And this mix of man and machine is probably the right way to realize Industry 5.0. And there's been some studies also. I have actually been to this line. I think it was in Taiwan or China. I can't remember exactly where it was. But they could change this laptop line in 30 minutes. And it was the same staff that worked in the factory that changed the whole line to produce a new kind of laptop. And it was very efficient. So there's a paradigm change here where the Industry 4.0 ideal is a lights-out factory, fixed installation. You press play, the machine produces this good for 7 years at a high volume, low cost. Where the future, I would say, is more about a lights-on factory where we make factories into more friendly workspaces where man and machine can share the workspace and create this high-margin products that I'm talking about now. So that was Industry 5.0. So just to quickly go through what's happening in Odense these days. So there's quite a vibrant robotics cluster in Odense. It's currently 10,700 employees in the companies, and it's growing very steeply. We expect like more than 60% annual growth over the coming years. So that's quite a journey. And I also just want to mention that after I sold Universal Robots, I invested in mobile industrial robots, which is in many ways the same one. So they had a product that, maybe you also know this one, but they had a product that could drive around, build maps, and it's actually in many ways the same idea that you take technology, you make it accessible to the factory staff, and then you allow them to use it as a tool to, create more value and be better at their work. And sure enough, this company we also sold to the same company, Teradyne, this time for $272 million. And as you can see on the analysis up there on the top right side, it's actually pretty similar what these two companies have done. They've made it intuitive to use the robots. They have put advanced sensors into the machines to make them more intuitive to use. Safety is important and flexibility is important. That's the technology side. The market strategy side is local manufacturing and testing, no in-house machines, but selling through distributors and then supporting those distributors. And that's the same, you can say, business model for both companies. And then for myself, I could buy a nice car, and I bought a very fast one, 0 to 100 in 2.3. And then I had to think about what I wanted to do with my life. So one Christmas evening, 4 or 5 years ago, my wife, we were eating this egg sandwich, and I was in life crisis because I had sold the companies. I didn't know what to do, and what should I do now, and who am I if I am not Universal Robots? So she said, what are you going to do about number one, and what are you going to do about number two? And the world really needs to do things. I mean, you can't just stop now. And that was like, oh, that's a lot of work, and how do we do this? And then we thought about making an education system because we realized education is probably key to a lot of these problems. But since we don't know anything about education, we decided to make robots that solve the world's problems. And that's actually the company that I'm working on today, the Reinvest Robotics, where we invest in robot companies that make the world a better place. That's what we try to do. And we're actually using robot technology to do that. We're using a control loop to do that. So the company is built around this control loop where we take the UN sustainability goals as the target value, and then the world is our system. And we do feedback loop like that. So we have invested in a number of companies all aligned with UN sustainability goals. One is this robot here for education where we teach children how to program with broccoli. Then we are working with a company that you can say this is a company in Industry 4.0. They have made this box that is an Industry 4.0 in a box, but in my perspective, this is Industry 5.0 because they make it easy to use Industry 4.0. And that's exactly the point of this company called Trendog. We have a company where we make farming robots. So here is this company called FarmDroid, where they seed by GPS and then they weed around it, and they do this. So it's also an interesting company. We have an underwater robot company here where this robot can build 3D maps of underwater structures. And I just want to show you one of these maps. So this is not a picture. This is actually a 3D map that is created by on an underwater structure. And if you see videos of divers doing these things, it's full of bubbles and all sorts of other things. So it makes a lot of sense actually to put robots down and build these 3D maps of underwater structures. Okay. And then here's a company that does corona testing or swabbing of the throat. And this is an AI-based approach where it identifies the back of the throat, and then the robot arm drives the swab into the throat and does the actual swab. And we made this company when the pandemic started, and then we ran into some problems that in Europe it's actually very hard to put products like this on the market because of regulation. And it's a little bit annoying because we very, very quickly had a product that could actually solve a need the world had, but in Europe we were not allowed to use it easily because of European regulations. I'll come back to that later. Actually, now I'll come back to that because then I'll come to the blockers of what I think is blocking the adoption of robotics and why it's not happening faster than it is. And I think in Europe there's a huge problem with all the regulations we are building up. So we all know GDPR, which is not strictly related to robotics, but all robotics companies need to deal with it anyway. Then in terms of drones, there's a lot of new regulation also, and can you fly beyond visual line of sight or not? And that's limiting a lot of adoption of the drone technology. Then we have the medtech. Now the medical device directive is changing into the medical device regulation, which is in effect from last year, but it has created a lot of turbulence in the market and what's legal and what's not legal, and it's actually blocking a lot of innovation. Then we have the AI Act coming, hopefully not soon, but it might come soon, which is, I think, a mess. And then also the machinery directive is being rewritten right now, and it's bundled together with the AI Act, and it can also create a lot of problems for European robotics industry, and especially related to the machinery regulation. And I happen to be an expert in that because we made robot arms that were supposed to work outside the cages, and that created a lot of, you can say, discussions with the local safety authorities in the various countries. So I know a lot about it, and I can also see how this new regulation that the EU is making is really going to be a big problem. So the definition of robot is it's always partly a completed machinery. You can't say a robot from the factory is a finished machine. And the problem is that if this robot has software in the safety functions, has AI in the safety function, then it's per definition a dangerous machine, which seems sensible. You don't want AI in your safety functions, but the problem lies in the definition of AI. And if you look in this definition of AI, it's machine learning approaches, unsupervised and reinforced learning. So all this, the top line is what we would call, AI in the broad sense. But then it's also logic and knowledge-based approaches. Okay, that's a lot of code. You would say search trees and any knowledge-based tables, databases, all gone. And then the last one is statistical approaches. That means filters. So if your robot has a filter in it, it's AI, and then it's by definition a dangerous machine. So if this goes through, it's going to be a complete disaster for the robotics industry, and it will mean that all robot installations, not from the factory, but per installation, needs to get third-party certified if this goes through. So I hope it doesn't. And there's a lot of other problems with this new regulation. I just want to hammer in the most obvious ones. Then you can say the investment environment in Europe is probably not as geared towards robotics as it should be. There's a lot of potential in robotics, but as always, startups are greedy, investors are also greedy, and to find each other is difficult. A lot of investors are used to IT investment, which has like a 6-month time constant. Robotics maybe have a 3-year time constant, but we know it's possible to invest with these time constants because medtech, medical devices, medicine and stuff, it's more than 6 years normally to get a product on the market there. So it should be possible to realize this investment environment, but I don't think it's there yet. And then there's also a general shortage of talent, but that's all over the world. So the enablers for future robotics. So AI is, going strong. Actually, not much happened in AI since the last 20 years, but now they use this ReLU function instead of the sigmoid function. From a theoretical point of view, that's more or less all that has changed in the last 20 years. But what has changed in practice is all the data how much new data is available and how that's possible. And of course the computing power. So now we have first the transition to GPUs and now dedicated AI chips, which will have a huge impact on what we can do with AI. And you can see here from this self-driving car video that the industry around self-driving cars is really pushing progress for using AI and advanced sensor technology, you would say. Personally, I'm a little bit more of a fan of LiDAR, which gives, I think, better results, but it's in a way similar to vision-based AI approaches, where it can also do tracking of objects around the cars. And all the research money that goes into this, both in the technology, but also in the application of the technology, will of course also impact robotics. And of course, a self-driving car is in many ways simply a robot. In the actuation side, actually not a lot have happened. So we know the servo motor, it's not changed a lot in the last many years, but I think there is beginning to be some change here. That's also driven by the automotive industry, where we have the reluctance motors and other new, little bit more exotic kinds of, you can say, takes on the electric motor. We have miniaturization. So here is a super tiny robot that's made with completely new processes, which of course opens up for robots inside the body for surgery. And one thing I'm very excited about is also, because it goes back to my PhD work with these self-changing robots, is this kind of foldable robots, where you can build super cheap small robots, because 2D processors are a lot cheaper than 3D processors, so you can actually make self-folding robots quite cheaply and get them to all sorts of application areas. I like this video also because it's also showing a new approach to actuation. So this is not computer graphics, but it's used to make computer graphics for the Spider-Man movies. This robot is launched into the air, and then it's using pneumatic actuators to actually make quite realistic human-like movements. I think the air capacity for this robot is only for a few minutes, so maybe only a few seconds. So it can probably only do this, but it's still a pretty impressive, you can say, actuation technology they have to realize this. And of course, it also has to be super robust to survive the impact when it lands. So I think it's pretty cool. Other drivers of robotics is actually the pandemic has driven a lot of robotics. It's easier to have robots coming to work than staff that might get sick. Supply chain disruption is of course also reshoring a lot of work. Out of time, 3 minutes, okay. Supply chain disruption is reshoring a lot of work. You can't have these super long supply chains anymore. Aging workforce, you need robots when people are too old to work. And of course, unfortunately, also the war is creating, you can say, new interest in robotics and producing closer. And EU is doing some things to try to incentivize this. My last statement is simply that I think robotics, there's going to be a huge explosion in robotics. We're going to see robotics coming out of the factories, as I also showed earlier, and into a lot of new application areas, and probably into the home sometime. I mean, this is a very serious attempt by Samsung to make a home robot, and it is probably going to go this way. And over time, the technology will be ready for these kinds of applications. So I think robotics is in a super exciting journey, and this is my last slide, which is interesting because if you look at the size of the IT industry in 2020, it's $5 trillion, 4% annual growth. The size of robotics industry in 2020 is $100 billion, so a lot smaller, but 26% annual growth. And if you do the math on that, those two curves will cross each other in 21 years, which means that in 30 years, robotics will be much larger than IT is today. So it's a huge growth, and personally I think it's going to go faster than this. I think we're just beginning to see the acceleration of robotics, and so there's an enormous potential in robotics. And my bet is that the next take on robotics will be, going out of the factories into logistics, is what we have seen in the recent years. Then after that, construction, maritime, offshore, food, agriculture, and health sector, and then sometime after that, you can say more into people's homes and our everyday lives. So I think it's a very exciting field to be in. Congratulations to everybody for being in robotics, and thank you so much.
Yeah,